Morning, everyone. This is Sundaratre. We are in lecture 10 for the Design to Manufacture at the University of Louisville. And we'll be looking at design exercise 3 that allows us to look at some aspects of minimizing costs. We are going to do that in the context of dealing with conflicting objectives. So you have a function and you could have several constraints. Let's look at three situations. One where you have only one objective, another time when you have two objectives, and thirdly, when you have, depending upon each of these three situations, you would have three different approaches that build off from properties or, more importantly, material indexes or performance indexes P. So, depending upon the first case where you have a single objective, you can use either a ranking system based on different properties or an index that is a combination of properties potentially. In the second case, when you have two objectives that could be conflicting, you could construct a trade-off plot or you could evaluate a penalty function. We shall focus on the situation where we construct trade-off plots for the two performance indexes. When you have more than two objectives, the analysis becomes a little bit more complicated and we have to create an exchange constant map. We might look into this down the line later in the class. To get us started again to think about functions, constraints, and objectives, let's take a situation where you want to replace a polystyrene package with something that is cheap as a packaging material, but you want to make sure it does not scratch or crack easily. So what is a material property that addresses cracking or scratching? Think about that. Because it's a packaging material, right, you're looking for commodity material, high volume, right? Typically plastics are used for that. So you're looking for something because shape is important, some kind of molding operation, for instance. And then you want to be able to minimize cost, right? You want something that's cheap. So this will give you an idea of, from a material selection perspective, how to list function, constraints, and objectives. Right? So for instance, you want transparency, you want moldability, and then you have to deal with fracture toughness and cost. So function is you're improving the packaging case, and the constraints are materials that are optically transparent, which are the best, so that you can showcase the product. How can you make it crack or scratch resistant, so fracture toughness better than polystyrene, and can you injection mold it? Objective is to minimize the material cost. The free variables are you can choose from the entire material universe possibilities that fit this category while minimizing cost.